Hello again, stupendous students of MSM3. We are going to continue looking at different types of transformations today. The last lesson was on translations. That was one type of transformation. And today is reflections. This is another type of transformation. Remember, a transformation is a change in a figure's shape, position, or size. So, a reflection is a flip across a line. The line is the line of reflection. So if we look here at these two pictures of Simba, this right here would be your line of reflection. The result is a mirror image of the original figure. So if I flip this Simba across the line of reflection, it would look, the figure gets flipped, so it looks like the two Simbas are looking at one another. To be a reflection, there are three properties. The first is the original figure and the image must be congruent. Second, corresponding points must be the same distance from the line of reflection. Well, okay, wait, what does that mean? So if I look at the tip of Simba's tail and I look at the same point on the other Simba, is this distance and this distance the same? Yes, it is. If I take the top of this ear and the top of this ear and I look, are those the same distance from the line of reflection? Yes, they are. And so I could do that with any point on these two Simbas, and the corresponding points would be the same distance from that line of reflection. And then finally, lines connecting the corresponding points, like what I just drew up here, must intersect the line of reflection at a right angle. So as I connect these corresponding points, does this line I drew, is that 90 degrees with the line of reflection? And it is. And if I look at the tail, and it is. If I did that with any other pair of corresponding points with these two Simbas, I would get these lines that make 90-degree angles. Okay, so you've got to have all three of these properties in order to be a reflection. So decide if each set of figures below are reflections. If it's not a reflection, we need to explain why not. We need to say which of these three properties it doesn't meet. So if I look at the first one, this lightning bolt, the figures appear to be the same size, but if I look here at the tip of the lightning bolts, is this point the same distance away from the line of reflection as that point? Clearly it is not. So no corresponding points are not the same distance from the line of reflection. And yes, you must write that all out. No, there are no abbreviations. That is what you must write. Okay, so let's look at B. Here's the corresponding point. Here's another corresponding point. And when I connect them, well, it looks like the points are the same distance from the line of reflection. But when I connect these 2 points, is that a 90-degree angle there? It is not. So this is not a reflection. So no lines connecting corresponding points don't intersect the line of reflection at 90 degrees. All right, there's that. Okay, letter C. Well, they are the same size, so that's good. Here's a pair of corresponding points. They appear to be the same distance away. It looks like a 90-degree angle. So yes, that is a reflection. And the last one. Clearly this is not a reflection because what happened? The shapes changed size. They are not congruent. So no, the figures aren't congruent. All right, now that we know what a reflection is, we are going to move into the coordinate plane. So figures can be reflected in the coordinate plane. Often they are reflected across the x-axis or the y-axis. You can reflect across all sorts of other lines in the coordinate plane, but oftentimes the x and the y-axis are used probably the most. So let's look at this figure here. Which axis was the figure reflected across? So we can see it got reflected right here. That is the x-axis. So let's give the original coordinates. So point L, you got to go over to -7 and then up to 5. So -7, 5. M is 0, 5. N is -2, 1. O is -5, 1. Now we need to do the image. Remember, the images are the ones with the little prime symbols there. So O prime and L prime and so on. So L prime is -7, -5. 0, -5 for M prime. N prime is -2, -1. And O prime is -5, -1. Okay, so now take a moment. Look at those coordinates that we just wrote. What do you notice? Well, if I look at my x values, they all stayed the same. So I reflected across the x-axis. The x location didn't change. I'm still at -2 for the n and the n prime. What did change though? My y coordinates. My y coordinates became the opposite. So if it was positive, it became negative. If it had been negative, it would become positive. So the x value remains the same. And the y value is the opposite. Okay, so let's move on to the next one. Which axis, this is going to be really hard to see in the video. Let me outline this. This is the shape. Okay, so there are the two shapes. So which axis was the figure reflected across in this one? This is the y-axis. Anybody have any guesses on what's going to happen? Because we did the x-axis. Now we're looking at the y-axis. My guess is it's going to be the opposite of what we just saw with the x-axis. So let's find out. So, oh, look at that. Spells out math. That is brilliant. All right, so the ordered pairs, the original coordinate, -4, 4 for M, -2, 2 for A, -3, 1 for T, and -5, 1 for H. So now M prime became 4, 4, 2, 2 for A prime, 3, 1 for T prime, and 5, 1 for H prime. So let's take a look. We reflected across the y-axis. What happened to my x coordinates? They became opposites. What happened to my y values? They stayed the same. So it is the opposite of what we said for up above. So if you understand x, what happens when you reflect across the x-axis, the y-axis is going to be the opposite of that. So the x value is the opposite, and the y value remains the same. Okay, and this is how it looks algebraically. So this xy, that's your original coordinates, x and y. This arrow shows you that you're doing some sort of transformation, and it leads us to these coordinates. So if I go across the x-axis, my x stays the same, and then my y becomes the opposite. That's what the negative shows us, that it's going to be the opposite. If I go across the y-axis, the x value becomes the opposite, the y stays the same. So the coordinates of a point and its image are given. Is the reflection across the x or the y-axis? So you got to look at what's going on. -4 became +4, but my y stayed the same. So x became the opposite, y stayed the same. Where does that happen? That was when we went across the y-axis. So this one got reflected across the y-axis. And then for the last one here, -3 stayed the same. And then, so the x stayed the same, y became the opposite. That means we went across the x-axis. All right, so that is it for reflections. We've got one more transformation left to do, and that is rotations. And we'll be right back with that coming up. Hope you enjoyed. If you have any questions, as always, reach out to your teacher. See you soon.